Let's talk domain. All right, so define the domain of functions. Remember your starting point, okay? You always want to start with the set of all real numbers. And then remember, in interval notation, that means negative infinity to positive infinity, okay? We have the two restrictions that we got to then look at. First off is when I have a rational function. Remember, rational function is fancy for fraction. I cannot divide by 0. So when you have that, you set your denominator to not equal 0. When you have a radical function, a square root function, you cannot take the square root of a negative number. So remember, the radical has to be positive or 0. So you set that greater than or equal to 0. All right. So 3 quick examples. First one, let's say I have a function looking like this. F of x is equal to 5x to the 7th minus 8x to the 4th plus 10x cubed minus 7x plus 1. Seems daunting, right? I know. So what do we always start with? Oh yes, the set of all real numbers. So I'm going to start with all real numbers. And then I look, do I have a rational function? I sure don't. I don't have a fraction. A radical function? Absolutely not. I'm not seeing anything. So my domain here, again, is the set of all real numbers and an interval notation, negative infinity to positive infinity, parentheses, infinity cannot be contained. Okay, let's go to the next one. Let's do g of x equals x minus 6 over x squared plus 7x plus 12. So I always start with the set of all real numbers. So I'm going to go ahead and start there. Then I check I have a rational function. So my denominator cannot equal 0. Okay? So I have to set that denominator to not be 0. So I get x squared plus 7x plus 12 cannot equal 0. Now, I solve this just like I solve a regular equation, okay? This is a quadratic, so let's go ahead, let's factor that thing, right? So x squared plus 7x plus 12, we know what multiplies to 12 to add to 7, 3, and 4. So that factors into x plus 3 times x plus 4. Cannot be 0. A little zero product property reminder. When you have this quadratic, you set both of them to what it is. So x plus 3 cannot be 0, x plus 4 cannot be 0. Okay? Because remember, you're trying to find the roots. So x here cannot be negative 3, x cannot be negative 4, but it can be every other real number. So let's do that in interval notation now with these two restrictions that we just found. Okay? So negative 4 and negative 3, those are my two set ones. So I can have every single value that is less than negative 4. So that is negative infinity all the way to negative 4. Yeah, that's my domain. Parentheses, and I put the parentheses because negative 4 can't be included. Then I can have every value in between negative 4 and negative 3. So that is in union with negative 4 to negative 3. Again, parentheses because it can't be included. And then I can have everything larger than negative 3, greater than. So in union with negative 3 all the way up to positive infinity. That would be my domain of that function. Okay, now let's go ahead. Let's do a radical function. So let's say I have this function. H of x equals the square root of 6x minus 18. So we know, again, that when I have a square root, that it has to be positive or has to be 0. So I'm going to go ahead and set 6x minus 18 greater than or equal to 0. And now we're just going to go ahead and solve that inequality. So that gets me 6x is greater than or equal to 18, and then x has to be greater than or equal to 3. So now if I do interval notation, greater than or equal to 3. That means that anything less than 3 is not going to satisfy it. 3 is going to be my starting point, and I put a bracket because 3 can be included. If I substitute 3 in, I'm going to get 0. That's fine. 3 all the way up to positive infinity. That is going to be my domain of that function.